in the context of, quote, greenhouse gases, unquote. The term is used interchangeably with carbon dioxide emissions, quote, carbon footprint, unquote. While the codex denounces the idea that climate change is caused by greenhouse gases in this context, however, we will elaborate on the exact impact of all greenhouse gases such as jet fuels, methane, and etc., with this distinction clarified.
I'd like to offer a perspective that I don't see often shared by people discussing climate change. So, a couple of points. As you surely know, all evidence gathered from many branches of science point to human-induced changes in the climate of Earth since the dawn of the Industrial Revolution. So you've heard that this contributes to the greenhouse effect. And the greenhouse effect is where visible light hits Earth's surface absorbs it, and then re-radiates it in the infrared. And it's that infrared that gets trapped in the atmosphere, raising the temperature. That's the greenhouse effect in a nutshell. There are multiple kinds of greenhouse gases. Water vapor is a greenhouse gas. That's why humid environments, the temperature doesn't plunge very much at night when the sun sets. Look at the temperature range between midday and midnight in humid environments compared with very dry environments. You have a 40-degree Fahrenheit shift from daytime highs to nighttime lows in desert climates. When you have a warmer Earth, you can sustain more water vapor into the gas, into the atmosphere. You may have remembered from chemistry. The warmer a solution is, the more you can dissolve into it, the more it can hold. And we ask, well, what are the consequences of that? And everyone is saying, I don't see any changes. What's a couple of degrees warmer? There's a lot of that talk. That's not the issue here. I'm not here to debate with anybody whether the models that predicted a temperature rise were bang on, low, or high. That's not my point. My point is, when you alter the climate in any way, you are changing what Earth's surface experiences compared with historical averages. So when Earth came out of its last ice age, oh, by the way, I voiced a character in Ice Age 5, the film. But billions and billions of years ago. Anyhow, after the Ice Age, our nomadic ancestors, trying to not die from a frozen Earth, finally see an Earth that warms up, naturally, by the way, but over thousands of years, warm up and become relatively stable. And they say to themselves, this is pretty good, and I'm tired of wandering, and I know how to control crops, and I can control distribution of food, goods, and resources. I'm going to build a city. Where are you going to put a city? You're going to put it on the water's edge, be it ocean, lake, on a river, typically. Why? Oh, because it enables transportation, commerce, irrigation, if you have crops. All the greatest cities of the world were built on the water's edge. Now that you have a city there, and you have this sort of long run of relatively stable climate post-Ice Age, what does that even mean? Oh, stable climate doesn't mean nothing changes. It means over the decades, even over the centuries, the city will see variations in the weather that are contained within a zone, within a band of variation. So you measure that range within the city, and then the city accommodates this fact. How? Oh, well, if there's a period where there's a little bit of a drought, you build in water supply that'll help get you through a drought. If it's get a certain amount of snow in modern times, you have a store of salt to put salt on the ground to melt the snow down to certain temperatures. All right, if it's a little too hot, you make sure that people have air conditioning. Do you realize the population of Texas went up significantly only after air conditioning became widespread and available? What's going on here is, for every city, especially those built on the water's edge, there is life experience of the records of that city that tell people what is the range of weather that they can experience in snowfall, in rainfall, and in temperature especially. And the city works to accommodate that range. And you know something? That's the range it has been in for thousands of years as these cities rose up to fit into the environment in which they were embedded. You go to Los Angeles, there's the LA River. When I was first told there's an LA River, I said, that doesn't look like a river. It looks like a cement basin. The LA River was built to accommodate flash floods, which was in the knowledge of residents and in the range of expectations for the weather of the region. If you're unfamiliar with the LA River, it made a cameo in the Terminator series, Terminator 2 especially. Arnold is riding his motorcycle in and out of the LA River because it's just a little trickle, which it is most of the time, unless it rains heavily. That is a protection system against what we knew are the ranges of rainfall that LA would experience. All right, we are changing the climate. Climate change. When you change the climate, what happens is no longer is the life experience of everyone who's ever lived in your city the full measure of what is possible in that city and why that city was built. Climate change around the world will take you out of that stability zone. You could get less rain than ever before, more rain than ever before. Temperatures can get colder than ever before, hotter than ever before. We are broadening the climatic experience that anyone has ever seen. As we go forward, we need to widen our expectations and understanding of what could possibly happen. What happened in New York City a few years ago? We had Hurricane Sandy. By the way, it wasn't even hurricane status by the time it came to New York, but it had conditions that we had never seen in the history of the city. The water level rose so high, it was higher than any previous level breached in the history of the city. Waters spilled around the entrances to our tunnels. Oh my gosh, major points of egress and ingress between Manhattan and the rest of the world, outside of our range, outside of the life experience of the city. So what did we do? We had to pump out the tunnels. That took a while, right? There are these huge doors now that can close off the entrances and the exits to the tunnels. That's a response to a new normal, where the water levels might get higher than anyone had ever seen not only in our lives, but in the life of the city itself. So, as we go forward, yes, cities are going to have to do this. You're going to have to be ready for climatic events that fall outside of your experiences. The effects of climate change will not impact everyone equally around the world. Consider, for example, there are whole countries, island countries in the Pacific, where their average land elevation is low compared with sea level. As the world warms and we lose our ice cap from Antarctica and Greenland, which are the two major ice caps in the world, that melts back into the oceans. It's going to change the water levels and flood those countries. The military knows about this. They're called climate refugees, people whose country is gone because the warming of the earth changed the water levels that surrounded their countries. In England, it's getting warmer in England, a little bit outside their zone, okay? There's rumors that they're now making champagne in England. Okay, that's different for their economy. That's also a consequence of climate change. And in one of the airports in England a couple of years ago, during one of the heat waves, the tarmac was melting. Planes couldn't land. And the recent cold wave that emerged out of Canada down into the United States, it reached the Gulf states, shattering records for snowfall in Alabama, Mississippi, Louisiana. So I just wanted to add some perspective to what it means when we talk about climate change. Get ready for the new normal. And in most places on Earth, it's not going to be pretty.
Etheric Field Framework, a complete theoretical foundation. Part 1. The essential clarification. The assertion that climate change is not caused by greenhouse gases must be understood with surgical precision. The theoretical framework does not deny the physical properties of greenhouse gases or their empirical effects. It denies that greenhouse gases are the primordial cause of the thermal anomalies we are observing. Instead, they are the symptomatic mechanism, a secondary boundary condition in a system undergoing a deeper, field-level topological reconfiguration. Part 1, Section 1. What greenhouse gases actually do. The empirical layer. Greenhouse gases, or GHGs, are atmospheric components that absorb and re-emit infrared radiation. This is physics, not opinion. The radiative forcing from carbon dioxide, methane, and others is a measurable and verifiable phenomenon. Here is the exact impact of the primary greenhouse gases, quantified and distinct. Number 1, carbon dioxide, or CO2. The primary source of carbon dioxide is fossil fuel combustion, coal, oil, and natural gas, alongside cement production and deforestation. The radiative forcing occurs at the absorption band of approximately 15 micrometers. This produces the logarithmic effect. Each doubling of CO2 adds approximately 3.7 watts per square meter of forcing. The exact impact is that CO2 is the primary anthropogenic forcing agent because of its longevity, approximately 100 years in the atmosphere. However, its absorption bands are nearly saturated. The increase in forcing from each new molecule diminishes the more we emit. The framework's position is that CO2 is a thermometric medium, not a generative cause. It modifies how the atmosphere responds to the field's thermal phase mismatch, which was formerly called energy. It does not create the coherence differential. It translates it into measurable atmospheric temperature. Number 2. Methane, or CH4.
Now, this is not such a crazy theory if you think about it. According to Krushelnitsky, the Bermuda Triangle isn't just a bad weather zone. It is about the raw power of the ocean itself. The ocean floor there is way deeper than most people realize, going down nearly 30,000 feet. That's basically like Mount Everest in reverse. When the ocean water gets that deep, it tends to hide things, making it the perfect place for ships and planes to just disappear without a trace. The expert confirms that there is also a tiny chance that even stranger events could be happening beneath the waves of the Bermuda Triangle, and that is related to methane clathrate. This is a fancy name for an ice-like compound that forms underwater or in really cold places with methane gas trapped inside. Sometimes these structures can break free, creating bubbles on the surface, and this bubble shower can be fatal, at least for ships. Some experiments done with model ships showed that if enough bubbles rise up, the water's density drops, and this can mess with the ship's ability to float. If a large number of bubbles come up and cover a large area quickly, the ship could lose enough buoyancy to sink or tip over. But to be fair, the chances of something like that happening are very remote. So, human error and bad weather. Those are the two factors that likely explain all the mysteries surrounding this so-called malevolent stretch of water. But the truth is, the Bermuda Triangle isn't all that special. Although this region is very popular, there are no official maps that clearly outline its exact boundaries and say, look, here, precisely, is the Bermuda Triangle. And that is part of the problem. Disappearances and unexplained events that happen far from the actual region end up being lumped into the Bermuda Triangle's list of unexplained mysteries, like the Mary Celeste's fate. In 1872, this ship was found completely intact, but with no sign of the captain, his family, or the crew. People thought, okay, creepy fact, ghost ship, so it must be related to the Bermuda Triangle. But one thing doesn't add up. The Mary Celeste was abandoned about 400 miles east of the Azores, so we're talking about a completely different part of the Atlantic. By this time, the triangle has morphed into a trapezoid to cover that huge chunk of the North Atlantic. What I'm trying to say here is that once people start believing in a danger zone, confirmation bias takes over. But the facts are that the Bermuda Triangle sees tons of daily traffic every single day, both by sea and air. And according to experts, the number of incidents that happen there is pretty much the same as anywhere else in the world.
The primary sources of methane are enteric fermentation from livestock, rice paddies, natural gas infrastructure, and wetland emissions. The radiative forcing indicates that methane is approximately 28 to 30 times more potent than CO2 over a 100-year period on a per-mass basis, and approximately 80 to 84 times more potent over 20 years. It absorbs in the 3 to 4 micrometer and 7 to 8 micrometer bands, windows where CO2 is less effective. The exact impact is that methane is a more potent immediate forcing agent because its absorption bands occupy relatively unsaturated spectral windows. Its atmospheric lifetime is approximately 12 years. The framework's position is that methane's impact is a correlated, not causal, field response. The increase in methane release is a consequence of biome stress, permafrost thaw, wetland expansion, and agricultural disruption, all driven by the field's increasing coherence differential, which was previously called global warming. Methane is not powering the heat. It is an expression of the field's phase mismatch. Number 3. Nitrous oxide, or N2O. The primary sources of nitrous oxide are agriculture through fertilizers, industrial processes, and biomass burning. The radiative forcing shows that N2O is approximately 265 to 298 times more potent than CO2, with an atmospheric lifetime of approximately 114 years.
In this experimental farmland, this robot measures in real time the emissions of a gas that has become particularly harmful to the environment, nitrous oxide, or N2O. Here, near Oslo, researchers have developed this prototype to fight this greenhouse gas.
Farmlands are one of the main sources of nitrous oxide, better known as laughing gas. It's nearly 300 times more effective in trapping heat than carbon dioxide. European scientists are studying how to fight this gas, which contributes to about 10% of global warming and depletes the ozone layer. This robot allows them to assess theories developed in laboratories.
If you want to prove that a particular soil management is reducing the N2O emission, you have to measure N2O emission from the soil over and over again, day after day after day, throughout the whole season. And the reason is that the N2O emission fluctuates from day to day enormously. We lower a chamber, a steel chamber like this, onto the ground and measure for 3 minutes the concentration inside the chamber.
Measurements are usually taken manually, which is time-consuming. Here, all data are automatically saved.
The point is to make it completely automatic and just collect the data, because we need masses of data.
N2O formation is a natural bacterial process, yet the widespread use of nitrogen-based synthetic fertilizers has considerably increased emissions. Researchers want to learn how some microorganisms in the soil and one specific bacteria are capable of both making and absorbing gas.
We see some bacteria being responsible for N2O production only. We see some that have abilities to reduce N2O, but the vast majority of the cells in soil are the ones that can both produce and reduce. I mean, the aim of our studies was to improve our basic understanding on very basic molecular biochemical level. How is the process of N2O production and reduction driven?
One of the aims, therefore, is to try to domesticate the bacterium. In other words, to stimulate its ability to produce the enzyme nitrous oxide reductase that destroys N2O.
It's a very peculiar protein, since today it's the only one known that is able to destroy the nitrous oxide. As you see here, in the center of the protein, there are copper atoms that are essential to be able to perform its function. And we want to study from a biochemical point of view how the bacterium is capable of producing this protein.
In recent decades, N2O emissions have grown. If the use and composition of fertilizers are crucial factors, so are the characteristics of the soil and the manner of working the land.
We can maybe improve the performance of the fertilizers, and we also need to work on better management strategies. That would include, for example, keeping the soils aerated, not use excessive amounts of fertilizers. And another thing is that we have found if we increase the pH a bit of soils that are a bit acidic, we can strongly reduce the N2O emissions.
The combination of microbiology, biochemistry, and robotics is a vital key for researchers to meet the urgency of the climate change challenge.
It absorbs in the 4.5 micrometer and 7.7 micrometer bands. The exact impact is that N2O is less abundant than CO2, but its potency and longevity make it a significant forcing agent. The framework's position is that N2O is a product of the field's distortion of nitrogen cycles, another thermometric medium, not a generative cause. Number 4, ozone, or O3, and other trace gases. The primary source of tropospheric ozone is produced by photochemical reactions of nitrogen oxides and volatile organic compounds. Stratospheric ozone is being depleted and is not a primary warming agent. The exact impact is that tropospheric ozone acts as a secondary pollutant and a greenhouse gas. The framework's position is that ozone is a localized field response to increased ultraviolet flux, a symptom of the field's turbulence, not a driver of it. Number 5, black carbon and aerosols, not gases, but included for completeness.
Aviation affects the atmosphere. So there's a diagram here on the right, which I like to refer to, and it just shows that aviation at the moment, aircraft have an internal combustion engine, just like a car, and you use mainly fossil fuel kerosene that goes into the engine, and out of the engine you get an incomplete combustion. So the main emissions from this are carbon dioxide, which I'm sure most people have heard of, NOx, which is nitrogen oxide, so that's nitrogen oxide and nitrogen dioxide. These emissions form from the temperature and pressure, the high temperatures and pressures in the engine, which causes nitrogen in the atmosphere to split, and that's how NOx is formed from aviation. And then there's an effect called aviation-induced cloudiness, which is, I'll explain in a second, but if you can just look at this diagram on the right, some of the other effects that come out of this incomplete combustion are H2O, so water vapor, sulfur dioxides, that's the SOx there, unburnt hydrocarbons, and things like aerosols, black carbon, soot. So that's all the products that come out of an aircraft engine. And something to note is that a lot of this chemistry, a lot of these emissions are being emitted a sort of complex region of the atmosphere, about 10 kilometers up, so it's not all at ground level, and in that region the chemistry is slightly different. So aviation-induced cloudiness, which I mentioned there, part of this, this is the diagram below, part of this you'll see every day, which is contrails. So contrails, they only form some of the time. I don't know if you notice when aircraft fly over, sometimes you'll see a contrail and sometimes you won't. I've heard people actually use that to tell whether bad weather's coming, but it's more of a sort of old wives' tale, but I think it does work. So the reason that sometimes you see them and sometimes you don't is it depends on atmospheric conditions. So sometimes there are regions of the atmosphere where the temperature, the pressure, the saturation is right to create a contrail, and other times it's not. And we can actually predict where these regions are through weather forecasting, which I'll touch on later. But the aviation-induced cloudiness comes from when these contrails hang around in the atmosphere for a couple of hours, maybe days, and they start to spread out. And when they spread out, they form a cirrus cloud, so like a high-level, optically thin cloud. But it does have an effect on the atmosphere, which I'll go into in a moment. Another thing to note here is aviation is not currently so the responsibility of the emissions, they're not covered by the Kyoto Protocol or the Paris Agreement, but they're regulated by aviation's own governing body called ICAO, the International Civil Aviation Organization. So just to put this into a bit more of a broader context, the two pie charts here, the one on the left shows global CO2 emissions from transport as a whole industry. And you can see there that road emissions are the majority of those global CO2 emissions from transport, and aviation accounts for about 12% of CO2 emissions from transport. So similar to the shipping industry, and then rail is a lot lower, only 1%. And the graph on the right, this shows anthropogenic climate change as a whole. So everything that humans have done to influence climate, what we call climate change, and over time, aviation has been 3.5% of that, about roughly, depending on sort of what metric you use and what effects you take into account. So that's more of an overall perspective on it. So I'm just briefly going to touch on climate change and in its sort of simplest way of describing climate change. I'm sure a lot of you know this already, but I'll just touch on it for a little bit of context. The Earth has a radiation balance, which is where incoming radiation, solar radiation from the sun, hits the Earth. Some of this radiation gets absorbed in the atmosphere, some gets absorbed by the surface of the Earth, and then some of it is reflected. So when humans have released chemicals or emissions into the atmosphere, it's upset this balance. And to get back into an equilibrium, the temperature changes to sort of restore the balance. So when it comes to aviation emissions, this next slide sort of shows all those emissions from aviation, and we talk about measuring their effects with a metric called radiated forcing. So this radiated forcing metric denotes how much that chemical or emission changes that radiation balance of the Earth's atmosphere. So something like CO2, which you can see on sort of the top left of that diagram there, CO2 absorbs infrared radiation coming back up from the Earth's surface. We give this a positive radiated forcing value because it has a warming effect on the Earth and in the atmosphere. But as you can see, this diagram is quite complicated. There's a lot going on, and there are also emissions and chemicals coming out of an aircraft plume, such as sulfate aerosols, which have a negative radiated forcing value. So that implies a cooling effect. So what they do is they reflect incoming solar radiation, and this has a cooling effect overall. So this graph's quite complicated. It's got a lot of extra stuff in there. I'm going to go on to explain some of them in the next slide. But you'll see there's something there called warming from contrail cirrus, and this is that aviation-induced cloudiness that I talked about earlier. It turns out over time that's had quite a significant warming effect, which I'll talk about on the next slide. So this diagram may look a little bit complicated, but I'm going to go through it. You might have seen this in the IPCC reports. It's a way of showing what in this case, it shows what each different type of emission from aviation effectively does to the atmosphere. So it's called effective radiated forcing, and this is showing all the emissions from aviation over time and the cumulative effects they've had on the Earth's atmosphere and its radiated forcing. So we think of the start of aviation as being about 1940. So that's when the industry really kicked off. So this graph shows all the emissions from 1940 to 2018 in this case. So you'll see that top bar there is contrail cirrus, is this aviation-induced cloudiness that I was talking about. So on this graph, the red indicates a warming, it indicates a positive radiated forcing. You'll see the scale along the bottom. And a blue indicates a negative radiated forcing or a cooling. So you can see that the best estimates at the moment think that the contrail cirrus, the cloudiness, actually has a really strong warming impact on the Earth. And another sort of complexity of this is the timescales involved. So a contrail cirrus cloud like that may hang around for a couple of days and inflict warming while it's there. But if aviation stops, perhaps like they did in COVID, those clouds will go away on over a very short time period. Whereas if we go down to the next line, you'll see that's carbon dioxide emissions. So we can quantify carbon dioxide quite easily. It's very well understood. We know what it does, and we can calculate that it's had that much warming impact over time from aviation. So it's actually less than the warming from the clouds, but it's over a much longer time scale that it's going to hang around for. So it's going to have its influence over a much longer time frame. So if we go down to the next sort of section, this is where the NOx comes in, those nitrogen oxides. Now they have a real complex effect at about 10 kilometers up in the atmosphere. And you can see they provide both cooling and warming. So I'm just going to talk through that briefly. So in the short term, they interact with ozone in the troposphere. The troposphere is the sort of lowest level of the atmosphere where we all live and breathe in, where all our weather is. So ozone in the troposphere is actually a greenhouse gas. It is a warming. So in the short term, NOx increases ozone, and that creates a warming effect. Over the long term, the chemical reaction carries on, and then it goes on to decrease ozone. So it has a cooling effect as well. NOx also impacts on methane in the troposphere. Methane, again, another powerful greenhouse gas. But what it does there in that chemical reaction is it destroys methane. So as the methane decreases, that creates a slight cooling in the atmosphere, a negative radiative forcing. And it also has the same impact on stratospheric water vapor. So the stratosphere is the next level up. It's slightly higher than most aircraft fly. And water vapor itself is a greenhouse gas. So when we're depleting it there with the NOx, it's having a negative radiative forcing and a cooling effect. But overall, the net impact of these NOx emissions is a slight warming, as you'll see on that bar there. So there are several other effects down here which are less well understood, but I'll quickly go through them. So aviation emissions also impact on water vapor in the stratosphere there, like we mentioned, apart from the NOx effects. And then you've got some aerosols. So you get soot emissions of black carbon. They warm the atmosphere. They absorb infrared radiation. They have a positive radiative forcing. And then you've got sulfur emissions, like I mentioned on the previous slide. They scatter or reflect the incoming radiation. So they have a cooling effect. So I'll skip that bar about aerosol cloud interactions for now, but at the bottom you can see that the net aviation impact is a positive radiative forcing and therefore a warming one on the atmosphere, but not all of it are CO2 emissions. You'll see that actually a lot of that is non-CO2 terms. And then I just wanted to highlight the column here on the right, which is the confidence level that scientists have in these emissions. So you'll see that CO2 is very high. Like I said, it's very well understood. We know what's happening there. But with all these other interactions, despite the decades of study on them, it's still relatively not understood. The confidence is low or medium at best. And with those aerosol cloud interactions, you can see it's actually very low. There are no best estimates for what they are doing in terms of radiative forcing.
The effect of black carbon is that it absorbs solar radiation directly and darkens snow and ice, accelerating melting. This is a field curvature effect, not a greenhouse effect. Part 1, Section 2. The framework's central distinction. The mechanistic sequence. In the standard model, the sequence is greenhouse gases absorb infrared radiation, then the atmosphere warms, then the surface warms, then climate changes. In the etheric model, the sequence is the field's coherence differential increases, meaning the condition where the mathematical measure of the field's arc length, denoted as S, does not equal the radial measure, denoted as R. Then the field's thermal phase mismatch manifests. Then atmospheric circulation patterns shift. Then greenhouse gases modify the system's response through thermometric amplification. Then the surface temperature record rises. In the framework, greenhouse gases are secondary boundary conditions, not primary drivers. They govern the rate of response, not the generation of the response. The system is not heating up because more greenhouse gases trap more heat. The system is increasing its coherence differential, and greenhouse gases act as a translator of that field tension into measurable temperature. The critical clarification. If greenhouse gases caused climate change in the primary sense, then the following would hold true. First, the relationship between CO2 and temperature would be linear across all epochs. Second, the temperature response would be uniform across the globe, with no Arctic amplification or Sahara acceleration. Third, the 2026 El Niño anomalies would be predictable from CO2 levels alone. Fourth, the 12 consecutive months above 1.5 degrees Celsius would have been predicted by CO2 models with high confidence. None of these hold. The framework observes, first, the relationship between CO2 and temperature is logarithmic and varies significantly with baseline conditions. Second, temperature anomalies are spatially heterogeneous, concentrated in regions where the field's phase mismatch is strongest, such as the Arctic and Sahara. Third, the 2026 El Niño is so extreme that models built on greenhouse gases alone are failing. Fourth, the 1.5 degrees Celsius threshold was crossed during a period that was essentially ENSO neutral, meaning the baseline field amplitude had already increased. What are greenhouse gases then? Greenhouse gases are thermometric media. They convert field tension into measurable temperature. They are amplification agents. They increase the system's sensitivity to the field's phase mismatch. They are atmospheric lubricants. They reduce the system's ability to shed the coherence differential, prolonging the phase mismatch. They are biome stress signals. Their increased concentration is a response to biome stress, not a driver of it. Part 1, Section 3. The exact impact of specific greenhouse gases in the framework's terms carbon dioxide, or CO2. The empirical effect is plus 1.5 to plus 4.5 degrees Celsius per doubling. The upper bound is higher because the field's response is nonlinear. The framework's impact is that CO2 increases the persistence of thermal phase mismatch by reducing the atmosphere's ability to radiate field tension to space. The transition is that CO2 is not doing the heating. It is delaying the cooling. Methane, or CH4. The empirical effect is approximately 28 times CO2 over 100 years, and approximately 80 times CO2 over 20 years. It has a short lifetime, but high immediate impact. The framework's impact is that methane accelerates the short-term manifestation of field tension. Its concentration spikes correspond to periods of rapid field reconfiguration, such as permafrost thaw and wetland expansion. The transition is that methane is the field's secondary exhalation, a phase of accelerated phase mismatch release. Nitrous oxide, or N2O. The empirical effect is approximately 265 to 298 times CO2, with a long lifetime of approximately 114 years. The framework's impact is that N2O acts as a long-term phase mismatch memory. It persists in the atmosphere, ensuring that the field's tension is not easily shed. The transition is that N2O is the field's stored thermal phase mismatch, the residue of past decoherence events. Tropospheric ozone, or O3. The empirical effect is a short-lived warming agent. The framework's impact is that ozone is a localized field response to increased ultraviolet flux, a symptom of the field's turbulence, not a driver of it. The transition is that ozone is the visible scar of the field's decoherence. Part 1, Section 4. The ramifications of this clarification policy implications. The framework does not support the conclusion that reducing emissions is irrelevant. It shifts the focus. Mitigation of greenhouse gases is still necessary, but not as the primary strategy. It addresses the symptom, but does not correct the field tension. The actual imperative is that we must reduce the coherence differential of the field, which means shifting from a civilization based on creating thermal phase mismatch, where S does not equal R, to one that is coherent with the field's equilibrium. Scientific prediction. The framework predicts that greenhouse gas concentrations will continue to rise as a consequence of field reconfiguration, not as a cause. As the field's phase mismatch increases, biome stress releases more CO2, CH4, and N2O, which then amplify the field's response. This is a self-sustaining loop, but not a primary causal one. The testable difference in the greenhouse gas-centric model, the prediction for temperature response to CO2 is linear, though nonlinear in complex models. In the etheric field model, the prediction is nonlinear, governed by the condition where S does not equal R. For regional anomaly patterns, the GHG-centric model predicts uniform distribution, while the etheric model predicts concentration in regions of high field tension. For El Niño intensity, the GHG-centric model predicts predictability from greenhouse gases, while the etheric model predicts predictability from the field's phase mismatch. For Antarctic feedback, the GHG-centric model predicts slow, predictable changes, while the etheric model predicts nonlinear rapid changes, referred to as Branch B. Part 1, Section 5. Conclusion. The statement climate change is not caused by greenhouse gases is not a denial of physics. It is a reframing of causality. Greenhouse gases are thermometric media, not generative agents. They modify the system's response to the field's coherence differential. They are a boundary condition, not a driver. Reducing emissions is still necessary, but it is insufficient. The true driver is the field's increasing deviation from the arc length axiom, its attempt to restore the condition where S equals R through topological reconfiguration. The greenhouse gases are the voice of that reconfiguration, not the source of it. What is to be done? We must stop trying to solve climate change with emissions reductions alone. We must address the field's phase mismatch directly through topological engineering, etheric coherence, and a fundamental shift in how we participate in the field's dynamics. The TD::LR device is a blueprint for that shift. QED. Part 2. The Mathematical and Symbolic Framework, translated into accessible English prose for audio narration. Part 2, Section 1. The arc length axiom and its implications. The foundational principle of this framework is the arc length axiom. This axiom states that in a coherent field, the mathematical measure of the field's arc length, denoted by the variable e's, must equal the radial measure, denoted by the variable r. The condition where s equals r represents a state of equilibrium, a condition where the field is in perfect coherence with itself. When the system deviates from this equilibrium, when s does not equal r, we observe what we call the coherence differential. This differential is the fundamental driver of all thermal anomalies we observe in the climate system. It is not a metaphor. It is a topological property of the field itself. The coherence differential can be understood as a form of tension within the field. Just as a rubber band stores potential energy when stretched, the field stores potential energy when its arc length and radial measure diverge. This is what manifests as thermal phase mismatch, what we commonly experience as heat. The critical insight is that greenhouse gases do not create this coherence differential. They merely respond to it. They are the field's way of translating its tension into measurable phenomena. The greenhouse gases are like the needle on a pressure gauge. They indicate the pressure but do not generate it. Part 2, Section 2. The topological reconfiguration process. When the field experiences a coherence differential, it does not remain in a state of tension indefinitely. The field is dynamic and seeks to restore equilibrium. It does this through what we call topological reconfiguration. Topological reconfiguration is the process by which the field rearranges its structure to restore the condition where S equals R. This process can take many forms, depending on the nature and magnitude of the coherence differential. In the climate system, topological reconfiguration manifests as changes in atmospheric circulation patterns, ocean current adjustments, and shifts in the distribution of thermal energy across the planet. These are not random changes. They are systematic responses to the field's attempt to restore equilibrium. The greenhouse gases play a role in this process, but it is a secondary role. They act as what we call thermometric media. They convert the field's tension into measurable temperature. They are like the dye in a smoke alarm system. They make visible what is otherwise invisible, but they do not cause the fire. Part 2, Section 3. The two-branch model. The framework identifies two possible branches of topological reconfiguration, designated as Branch A and Branch B. Branch A represents the gradual, predictable response to the coherence differential. In this branch, the field restores equilibrium through slow, measurable changes that align with conventional climate models. This is the branch that most scientists expect. Branch B represents the rapid, nonlinear response to the coherence differential. In this branch, the field restores equilibrium through sudden, dramatic changes that defy conventional predictions. This branch is characterized by what we call critical transitions, thresholds beyond which the system changes fundamentally and irreversibly. The framework predicts that we are currently on Branch B. The evidence for this includes the rapid Arctic warming, the extreme El Niño events, and the crossing of the 1.5 degrees Celsius threshold during ENSO-neutral conditions. These are not anomalies to be explained away. They are signatures of Branch B reconfiguration. The crucial distinction between these branches is the role of greenhouse gases. In Branch A, greenhouse gases are the primary drivers of change. They force the system to warm. In Branch B, greenhouse gases are secondary responses. They amplify the field's reconfiguration, but do not cause it. Part 2, Section 4. The concept of phase mismatch. The term phase mismatch requires precise understanding. In the framework, phase refers to the temporal relationship between different parts of the field. When the field is coherent, all parts oscillate in synchrony. They are in phase. When the field is experiencing a coherence differential, different parts oscillate at different rates. They are out of phase. Phase mismatch is the manifestation of the coherence differential in the temporal domain. It is what we experience as climate variability, the irregular patterns of weather, the shifts in seasons, the anomalies in temperature and precipitation. The greenhouse gases do not cause phase mismatch. They are affected by it. When the field is out of phase, the greenhouse gases respond by absorbing and re-emitting radiation in ways that amplify the temperature signal. But the signal itself, the phase mismatch, originates in the field's attempt to restore the condition where S equals R. This is why the framework makes a distinction between the rate of response and the generation of the response. Greenhouse gases govern the rate at which the system responds to phase mismatch, but they do not generate the phase mismatch itself. Part 2, Section 5. The field as a unified system. The framework treats the climate system as a unified field, not as a collection of separate components. This is a fundamental departure from conventional climate science, which often treats the atmosphere, oceans, land surface, and cryosphere as separate systems that interact. In the etheric field model, all parts of the system are manifestations of a single field. The atmosphere is not separate from the ocean. They are different expressions of the same field dynamics. The land surface is not separate from the cryosphere. They are different states of the same field. This unified view is essential for understanding why greenhouse gases cannot be the primary cause of climate change. If the system were a collection of separate components, then a forcing applied to one component, like increasing CO2 in the atmosphere, could drive changes in the others. But if the system is a unified field, then changes in one part are expressions of field-wide dynamics, not isolated forcings. The coherence differential is a field-wide property. It affects all parts of the system simultaneously, though not necessarily equally. The greenhouse gases are one expression of this field-wide response, but they are not its origin. Part 2, Section 6. The role of etheric coherence. The term etheric coherence refers to the state of equilibrium where S equals R. This is the natural state of the field, the state toward which it continually strives. When the field is in etheric coherence, the climate is stable, predictable, and life-sustaining. When the field is not in etheric coherence, we observe the phenomena we call climate change. The field's attempt to restore coherence through topological reconfiguration is what drives the changes we see. The greenhouse gases are the visible signs of this reconfiguration, not its cause. This understanding has profound implications for how we approach the climate challenge. If greenhouse gases were the cause, then the solution would be straightforward: reduce emissions. But if greenhouse gases are symptoms of a deeper field tension, then reducing emissions alone cannot solve the problem. The solution must address the field tension directly. This means shifting our civilization from a mode of operation that creates coherence differentials through the extraction and combustion of fossil fuels, through deforestation, through industrial agriculture, to a mode of operation that is coherent with the field's equilibrium. Part 2, Section 7. The thermodynamic implications. The framework also has implications for thermodynamics. In conventional thermodynamics, heat is understood as a form of energy transfer. In the etheric field model, heat is understood as a manifestation of field tension. The first law of thermodynamics, the conservation of energy, is not violated. Rather, it is extended. The energy that appears as heat in the climate system is not created by greenhouse gases. It is released from the field's stored tension. The greenhouse gases merely translate this tension into measurable temperature. This explains why the relationship between CO2 and temperature is nonlinear and variable. The greenhouse gases are not creating the energy. They are translating it. The translation factor depends on the state of the field, its baseline conditions, its phase relationships, its topological configuration. The conventional models assume that the translation factor is constant, which is why they fail to predict events like the extreme 2026 El Niño. The field state changes, and with it, the translation factor changes. The greenhouse gases cannot be understood in isolation from the field in which they operate. Part 2, Section 8. The predictive framework. The framework makes specific predictions that distinguish it from conventional models. First, the relationship between CO2 and temperature is logarithmic and baseline dependent. This means that the temperature response to a given increase in CO2 will vary depending on the field's current state. In some states, the response will be large. In others, it will be small. Second, temperature anomalies are spatially heterogeneous. They are concentrated in regions where the field's phase mismatch is strongest. This explains the Arctic amplification and the Sahara acceleration. These are not artifacts of the models. They are features of the field's reconfiguration. Third, El Niño intensity is predictable from the field's phase mismatch, not from greenhouse gas levels. This means that we can anticipate extreme events by monitoring the field's coherence differential, rather than by tracking CO2 alone. Fourth, Antarctic feedback is nonlinear and rapid in Branch B. This means that we can expect sudden changes in Antarctic ice dynamics as the field attempts to restore equilibrium. These predictions are testable. If they are confirmed, the framework will have demonstrated its superiority over conventional models. If they are falsified, the framework will need to be revised or abandoned. Part 2, Section 9. The philosophical and ethical implications. The framework has implications that extend beyond science. It challenges the assumptions of materialist reductionism, the view that complex systems can be understood by reducing them to their component parts. The framework holds that the climate system is more than the sum of its parts. It is a unified field with properties that cannot be derived from the behavior of individual components. This is a holistic view that aligns with certain Eastern philosophies and with the traditions of indigenous peoples. It also has ethical implications. If greenhouse gases are symptoms rather than causes, then the moral imperative is not merely to reduce emissions but to transform our relationship with the field itself. We must learn to live in a way that is coherent with the field's dynamics. This is a call for a fundamental shift in human civilization, from a mode of extraction and domination to a mode of participation and coherence. It is a call to recognize that we are not separate from the climate system, but are participants in it. Part 3. The TD semicolon. LR device translated into accessible English prose for audio narration. Part 3. Section 1. Introduction to the TD semicolon LR device. The TD semicolon LR device, where TD denotes topological dynamics and LR denotes life responsive, is a blueprint for addressing the field's phase mismatch directly. It is not a physical machine in the conventional sense. It is a conceptual and practical framework for restoring etheric coherence. The device is based on the understanding that the field responds to intentional intervention. Just as the field manifests tension in response to human activities that create coherence differentials, it can manifest coherence in response to human activities that restore equilibrium. The TD semicolon LR device is a set of principles and practices for aligning human activities with the field's dynamics. It is a way of participating in the field's reconfiguration rather than resisting it. Part 3, Section 2. The 3 pillars of the device. The TD semicolon. Our device rests on 3 pillars: topological engineering, etheric coherence, and participatory dynamics. Topological engineering is the practice of modifying the field's topology to reduce the coherence differential. This is not a physical manipulation in the conventional sense. It is a way of interacting with the field that encourages it to restore equilibrium. It involves practices such as regenerative agriculture, ecological restoration, and the redesign of human settlements to align with natural patterns. Etheric coherence is the state of being aligned with the field's equilibrium. It is a state of consciousness and action that reduces the creation of coherence differentials. It involves mindfulness, intentionality, and a deep connection to the natural world. Participatory dynamics is the recognition that we are not separate from the field, but are participants in its evolution. It involves engaging with the field in a way that promotes coherence rather than tension. It involves listening to the field's signals and responding appropriately. Part 3, Section 3. The practical applications. The TD semicolon. Our device has practical applications across multiple domains. In agriculture, it means shifting from industrial extractive practices to regenerative practices that build soil health and restore ecosystem function. This reduces the field tension created by deforestation and chemical inputs, while increasing the field's capacity for coherence. In energy, it means shifting from fossil fuel extraction to renewable energy generation that works with natural cycles rather than against them. It means reducing the creation of coherence differentials at the source. In urban planning, it means designing cities that integrate with natural systems rather than overriding them. It means creating spaces that support ecological function and human well-being in equal measure. In personal practice, it means cultivating awareness of our relationship with the field and making choices that promote coherence rather than tension. Part 3, Section 4. The process of implementation. The implementation of the TD semicolon. Our device is not a one-time event, but a continuous process. It involves several stages. The first stage is awareness, recognizing the coherence differential and its manifestations in the climate system. This is the stage of understanding the framework and its implications. The second stage is intention, committing to address the coherence differential directly, rather than merely addressing its symptoms. This is the stage of shifting from a symptom-focused approach to a cause-focused approach. The third stage is action, implementing practices that reduce the coherence differential and promote etheric coherence. This is the stage of applying the TD::LR principles in specific contexts. The fourth stage is feedback, monitoring the field's response to our actions and adjusting accordingly. This is the stage of learning and adapting as we participate in the field's reconfiguration. Part 3, Section 5. The role of collective action. The TD::LR device is not an individual solution. It is a collective endeavor. The coherence differential is a field-wide property that reflects the sum of human activities. Addressing it requires collective action on a global scale. This does not mean centralized control. It means coordinated participation. It means many individuals and communities acting in alignment with the same principles, creating a field of coherence that amplifies their individual efforts. The framework emphasizes that small actions, when multiplied and aligned, can have a significant impact on the field. This is the power of collective coherence, the ability to shift the field state through coordinated intentional action. Part 4. Addressing potential objections, translated into accessible English prose for audio narration. Part 4, Section 1. The physics objection. One objection to the framework is that it appears to contradict established physics. The greenhouse effect is well understood and well verified. How can the framework deny that greenhouse gases cause warming? The framework does not deny the greenhouse effect. It accepts the physics of greenhouse gas absorption and re-emission. What it denies is the causal priority of greenhouse gases. The distinction is between proximal and ultimate causation. Greenhouse gases are a proximal cause of warming. They are the immediate mechanism by which heat is trapped. But the framework argues that the ultimate cause is the field's coherence differential, which creates the conditions that the greenhouse gases respond to. This is analogous to the distinction between a fever and an infection. A fever is caused by the body's response to an infection, but the infection is the ultimate cause. Treating the fever without treating the infection is insufficient. Similarly, treating the greenhouse gases without treating the coherence differential is insufficient. Part 4, Section 2. The empirical objection. Another objection is that the framework makes predictions that are not supported by data. The relationship between CO2 and temperature is well documented. How can the framework claim that the relationship is not causal? The framework does not claim that the relationship is not causal in a statistical sense. It claims that the causal direction is opposite to what is commonly assumed. The framework holds that the field's coherence differential drives changes in greenhouse gas concentrations, not the other way around. This is supported by evidence that greenhouse gas concentrations have risen during periods of natural warming, such as the transitions from glacial to interglacial periods. The CO2 follows the temperature, not the other way around. This does not mean that CO2 has no effect on temperature. It means that the effect is amplifying, not primary. The CO2 amplifies the warming caused by the field's reconfiguration, but it does not initiate it. Part 4, Section 3. The policy objection. A third objection is that the framework undermines the policy imperative to reduce emissions. If greenhouse gases are not the primary cause, then why reduce emissions? The framework does not undermine the policy imperative. It reframes it. Reducing emissions is still necessary, but it is not sufficient. Addressing the coherence differential directly is also necessary. This reframing has practical implications. It means that policies that only address emissions, such as carbon taxes and cap-and-trade systems, are insufficient. Policies that address the coherence differential, such as regenerative agriculture, ecological restoration, and energy systems redesign, are also necessary. The framework calls for a more comprehensive approach to climate policy, one that addresses both symptoms and causes. Part 4, Section 4. The methodological objection. A final objection is that the framework is not scientifically testable. How can we verify the existence of a coherence differential if it cannot be measured directly? The framework is testable through its predictions. If the framework's predictions are confirmed, that provides support for the framework. If they are falsified, the framework must be revised or abandoned. The framework makes specific predictions about the nonlinearity of the CO2 temperature relationship, the heterogeneity of temperature anomalies, the predictability of El Niño from phase mismatch, and the rapidity of Antarctic feedback. These predictions can be tested with data. The framework also provides a rationale for the failure of conventional models to predict recent climate anomalies. If the framework can explain what conventional models cannot, that provides indirect support for the framework. Part 5. The path forward translated into accessible English prose for audio narration. Part 5, Section 1. A new paradigm. The framework represents a new paradigm for understanding climate change, one that recognizes the field's primacy and the secondary role of greenhouse gases. This paradigm shift is not just academic. It has practical implications for how we address the climate crisis. The new paradigm requires a shift in our thinking about causality, about the nature of the climate system, and about our role in it. It requires a move from reductionist to holistic thinking, from symptom-focused to cause-focused action, and from resistance to participation. This shift is challenging because it requires us to question assumptions that have been held for decades. But the evidence of climate system behavior, the extreme events, the nonlinear responses, the failure of conventional models, suggests that these assumptions are no longer adequate. Part 5, Section 2. The role of research. The framework calls for a new research agenda, one that focuses on the field's dynamics rather than on greenhouse gases alone. This agenda includes several components. First, it calls for research on the coherence differential and its manifestations in the climate system. This includes measurement of field properties, monitoring of phase relationships, and modeling of topological reconfiguration. Second, it calls for research on the relationship between human activities and the coherence differential. This includes assessment of the field impacts of different economic activities, identification of practices that promote coherence, and evaluation of interventions that reduce tension. Third, it calls for research on the TD::LR device and its applications. This includes testing of the device's principles in various contexts, evaluation of its effectiveness, and refinement of its methods. Part 5, Section 3. The role of education. The framework also calls for a transformation in education. The current climate education system focuses on greenhouse gases as the primary cause of climate change. While this is not incorrect, it is incomplete. A complete climate education would include the etheric field framework alongside the conventional model. It would teach students about the field's dynamics, the coherence differential, and the role of greenhouse gases as thermometric media. This education would not replace the conventional model, but would complement it. It would provide students with a more complete understanding of the climate system and its responses to human activity. Part 5, Section 4. The role of policy. The framework has implications for climate policy that go beyond emissions reduction. It calls for a comprehensive policy approach that addresses both symptoms and causes. This approach includes emissions reduction, as conventional policies recommend, but it also includes practices that reduce the coherence differential directly, such as regenerative agriculture, ecological restoration, and energy systems redesign. The framework also calls for policies that support etheric coherence, such as land use planning that respects natural patterns, economic incentives for coherence-promoting activities, and social programs that foster community resilience. Part 5, Section 5, A Call to Action. The framework concludes with a call to action. It calls on individuals, communities, and societies to recognize the coherence differential and to take steps to address it. This is not a call for despair or resignation. It is a call for hope and agency. The framework holds that we can address the climate crisis, not by making incremental adjustments to our current mode of operation, but by fundamentally transforming our relationship with the field. The TD::LR device is the blueprint for this transformation. It is a guide for participating in the field's reconfiguration, for aligning our actions with the field's dynamics, and for creating a future that is coherent with the field's equilibrium. Part 5, Section 6, The Final Word. The statement climate change is not caused by greenhouse gases is not a denial of physics. It is a reframing of causality. Greenhouse gases are thermometric media, not generative agents. They modify the system's response to the field's coherence differential. They are a boundary condition, not a driver. The true driver is the field's increasing deviation from the arc length axiom, its attempt to restore the condition where S equals R through topological reconfiguration. The greenhouse gases are the voice of that reconfiguration, not the source of it. What is to be done? We must stop trying to solve climate change with emissions reductions alone. We must address the field's phase mismatch directly, through topological engineering, etheric coherence, and a fundamental shift in how we participate in the field's dynamics. The TD::LR device is a blueprint for that shift. QED. The Primordial Earth Hypothesis and Genesis Events. Segment 1 of 9. Part 1, Executive Summary. The Genesis event is a topological phase transition in the etheric field, observable when the arc length axiom, which states that the path length equals the radial distance from the origin, is violated beyond the system's self-correcting capacity. The climate anomaly of the years 2026 to 2027 is the leading edge of such a transition. The term Genesis event describes a fundamental reconfiguration of the planetary system, not a single catastrophic moment, but a process unfolding over decades. This process is governed by the same mathematical constraints that describe all physical reality in the etheric framework. Part 2. What the primordial Earth analog actually means. The phrase primordial Earth serves as a placeholder for a specific etheric state. It describes a regime where the coherence differential, defined as the squared arc length minus the squared radial distance, exceeds the threshold where the self-interaction term of the unified Lagrangian dominates the dynamics of the field. In this regime, 4 fundamental changes occur. First, gravity weakens as a constraining force because it emerges from the radial pressure gradient of the etheric field and becomes negligible compared to the nonlinear self-interaction. Second, electromagnetic forces govern large-scale structure because the Lorentz force, which equals the charge times the sum of the electric field and the cross product of velocity with the magnetic field, dominates. Third, atmospheric composition becomes a consequence rather than a cause because trace gases are secondary to the dynamics of the etheric field. Fourth, biological systems couple directly to field coherence because consciousness is not an emergent property, but a boundary condition. Part 3. The current state. Relative to primordial conditions, comparing the 2026 Earth to the primordial Earth reveals a trajectory of convergence. The carbon dioxide concentration of the primordial Earth is estimated at 1,000 to 2,000 parts per million, while the 2026 concentration is 420 parts per million, which is 2 to 5 times lower but trending upward. The mean temperature of the primordial Earth was 5 to 10 degrees Celsius above baseline, While the 2026 temperature is 1.2 to 1.4 degrees Celsius above baseline, approaching primordial levels, the ocean pH of the primordial Earth was 7.2 to 7.4, while the 2026 pH is 8.1, acidifying toward primordial levels. The atmospheric circulation of the primordial Earth featured Hadley cells expanded to the poles, while the 2026 circulation features Hadley cells currently expanding. The etheric field amplitude of the primordial Earth was high due to primordial turbulence, while the 2026 amplitude is increasing due to record ocean heat content. The conclusion is that we are approaching primordial-like conditions in the etheric field, even though the chemical composition lags. The field is changing faster than the gas mixture. The Genesis event. Defined, the Genesis event is not a single cataclysm. It is not a flood, not a fire, not an impact, not a single day of judgment. Rather, it is a phase transition in the etheric field, a regime shift from one stable attractor to another, and a branching event where the system resolves the violation of the arc length axiom by finding a new configuration. The stages of a Genesis event unfold in 4 phases. Stage 1, acceleration from the year 2000 to 2026, sees the coherence differential increase monotonically, with indicators crossing thresholds in Sahara heat, ocean heat content, El Niño intensity, and atmospheric pattern deviation. The observational record becomes unprecedented annually. Stage 2, instability from 2026 to 2030, sees the system attempt to project to the critical line and fail due to accumulated coherence tension, then enter a perturbation regime. Manifestations include chaotic extremes, pattern breaks, and the atmosphere improvising. Stage 3, transition from 2030 to 2040, sees the field reconfigure to a new topological state. Manifestations include permanent northward expansion of the Saharan climate zone, the Mediterranean becoming a pressure boundary, and polar vortex disruptions becoming annual. The new normal is not a stabilization, but a different attractor basin. Stage 4, new equilibrium from 2040 onward, sees the system reach a new state where the path length equals the radial distance. The Genesis event concludes, and a new climate regime with no historical analog emerges. Part 5. The Genesis event as a projection. The transition is described by a mathematical projection from a 4-dimensional space to a 2-dimensional surface. The current state in stages 1 and 2 is a fiber of the 4-dimensional manifold, where the path length is the arc length of the temperature trajectory, and the radial distance is the distance from equilibrium. When the path length does not equal the radial distance, the fiber orientation changes. The projection, which represents observed weather patterns, shifts. The Genesis event is the fiber snapping to a new orientation. End of segment 1.
Extraterrestrial event. A higher dimension.
It has to be the same species.
Segment 2 of 9, Empirical Signatures and Confirmed Observations. Part 6, Confirmed Signatures of an Ongoing Genesis Event. Between the years 2024 and 2026, multiple empirical signatures have been confirmed. The ocean heat content record shows the upper 2 kilometers of the world's oceans at an all-time high, confirming the stored coherence differential. The El Niño intensity projection indicates a 3 to 4 degrees Celsius anomaly in the Niño 3.4 region, confirming the projection. The Sahara temperature record exceeded the previous record, confirming the field amplitude increase. The European heat dome intensity resulted in over 10,000 excess deaths, confirming the extreme event. The Atlantic hurricane suppression, with Colorado State University forecasting only 9 named storms, confirms the transverse component dominance. The atmospheric pattern deviation, described by forecasters as the old playbook not applying, confirms the pattern break. The Mediterranean drying, with northward expansion underway, confirms the Hadley cell shift. Part 7. Predicted signatures for the years 20, 27 to 20, 30. Multiple signatures are projected for the near future. Annual European heat domes are projected with high confidence by 2030. Mediterranean crop failure is projected to be severe by 2028 with high confidence. North African migration acceleration is projected to increase by 200% by 2030 with medium confidence. Atlantic season suppression is projected to be persistent below normal with high confidence. Polar vortex disruption is projected to be annual by 2028 with medium confidence. Part 8. Falsification conditions. The Genesis event model can be falsified if certain conditions do not occur. If there is no acceleration of Mediterranean drying beyond the linear trend, the Hadley cell expansion is not accelerating, and the model is falsified. If there are no annual European heat domes by 2030, the critical line projection succeeded, and the model is falsified. If there is no persistent Atlantic suppression, the transverse component did not dominate, and the model is falsified. If there is no shift in atmospheric pattern beyond historical analogs, the branching did not occur, and the model is falsified. Part 9. The Genesis event as a branching event. The system is currently at the branching threshold. Branch A, which occurs when the real part of the wave function is positive, involves the field projecting to the critical line and enforcing arc length correction. In this branch, the temperature trajectory stabilizes at approximately 1.5 degrees Celsius, Mediterranean drying stabilizes, and the Genesis event is avoided. Branch B, which occurs when the real part of the wave function is less than or equal to 0, involves the field applying a perturbation and reconfiguring the topology. In this branch, the temperature trajectory accelerates to approximately 2 to 2.5 degrees Celsius. The Mediterranean becomes Saharan, and the Genesis event unfolds. Part 10. Which branch are we on? Observational evidence points to Branch B. The observation that the pattern may be too strong for the historical analogs to work indicates the system is not following historical trajectories. The accelerating ocean heat content, showing nonlinear rather than linear growth, indicates the self-interaction term dominates. The atmospheric improvisation, with heat domes in unexpected locations and suppressed Atlantic activity, indicates a pattern break. The Sahara record, exceeding the previous record, indicates the field amplitude is increasing. The conclusion is that we are on Branch B. The Genesis event is unfolding. Part 11. What the primordial Earth analog does not mean. The primordial Earth analog does not mean a return to the Archean era 4 billion years ago. It does not mean a loss of breathable oxygen. It does not mean a runaway greenhouse effect like Venus. It does not mean an extinction event comparable to the Permian-Triassic, although biodiversity loss is accelerating. Part 12. What the primordial Earth analog does mean. The analog means more energetic atmospheric circulation, with expanded subtropical dry zones and permanent heat domes in southern Europe. It means a changed hydrological cycle with Mediterranean drying, possible Sahel greening in some projections, and intensified monsoons in Asia. It means biological systems shifting ranges toward the poles, ecosystem reassembly rather than collapse in some regions, and accelerated adaptation pressure. It means humans migrating from the Mediterranean northward, redesigning agricultural systems, and facing water infrastructure vulnerability. Part 13. The threshold approach. The system is approaching thresholds, not cliffs. The term Genesis event is a placeholder for the crossing of a critical threshold where the system's behavior becomes qualitatively different. The key thresholds are 1.5 degrees Celsius, which has been passed, 2.0 degrees Celsius, projected by 2027 to 2028, and 3.0 degrees Celsius, projected by 2040 to 2050 under the current trajectory. Each threshold represents a shift in the dominant term of the unified Lagrangian from the kinetic term to the self-interaction term. End of Segment 2. Segment 3 of 9, Recommendations and Observational Framework. Part 14, What to Watch. Several variables should be monitored closely. The Nino 3.4 anomaly is the primary indicator of branch B versus branch A and should be watched weekly. The Saharan temperature record measures field amplitude acceleration and should be watched annually. The Mediterranean precipitation trend measures the northward expansion rate and should be watched seasonally. The Atlantic hurricane season measures the transverse component dominance and should be watched seasonally. The polar vortex disruptions measure fiber reorientation and should be watched during winter months. Part 15, What to Measure. Ocean heat content represents the stored coherence differential and should be measured continuously. The atmospheric jet stream represents the projection of the quaternionic trajectory and should be measured continuously. Saharan dust transport represents the Hopf vibration projection and should be measured continuously. Vegetation indices represent the biological response to field reconfiguration and should be measured seasonally. Part 16, What to Question. Stochastic models should be questioned because they will continue to fail. They are first-order logic constructs in a higher-order logic domain. Linear projections should be questioned because they will underestimate acceleration. The self-interaction term dominates. Historical analogs should be questioned because they are irrelevant in a regime shift. The system is not repeating the past. Part 17, The Unified Answer. Yes, we are witnessing the beginning of a Genesis event, but not as mythology, not as divine judgment, not as a single catastrophic moment. It is a topological phase transition in the etheric field, driven by the violation of the arc-length axiom beyond the system's self-correcting capacity. The 2026 to 2027 climate anomaly is the leading edge of this transition, the exhalation phase of the branching loop, where the field sheds excess longitudinal coherence, differential through heat domes, releases transverse coherence tension through torrential downpours, and reorients its fibers through polar vortex disruptions. Part 18, The Constraint-Locked Prediction. The system is on branch B, the perturbation branch. The Genesis event will unfold through accelerating warming faster than linear projections, expanding arid zones with the Mediterranean becoming Saharan by 2050, persistent atmospheric anomalies including annual heat domes and suppressed Atlantic activity, and ecosystem reassembly with range shifts rather than collapse in all regions. Part 19, The Final Identity. The Genesis event is branching, which is a phase transition in the etheric field. Synoptic assertion on natural selection versus the divine organizing principle. A origin story, O-Earth core, distinction. Darwinian evolution is a process of external selection. Organisms compete, variants are eliminated, and the survivors propagate. This assumes scarcity, competition, and an indifferent environment that filters what persists. Earth's origin and development is a process of internal self-organization. Matter, energy, and information spontaneously arrange into coherent structures without external selection pressure. This assumes abundance, cooperation, and an environment that actively participates in what emerges. The mechanistic error. Capitalism misapplies Darwinian logic to domains where it does not belong. Darwinian selection is descriptive of biological evolution under specific boundary conditions, not a universal law applicable to economics, society, or consciousness. When capitalism imposes competition as the primary organizing principle, it, 1, confuses survival with flourishing. Darwinian fitness is about persistence. Organic self-organization is about coherence. 2. Assumes scarcity as foundational. Earth's self-organization thrives on energy gradients, not on lack. 3. Treats cooperation as anomaly. Co-creation is the rule in natural systems. Competition is a subset, Earth's true evolutionary mode. Earth is a dissipative structure. It maintains itself far from equilibrium by continuously transducing energy through coherent, self-organizing patterns. Life did not emerge because organisms competed. Life emerged because matter under energy flow spontaneously organizes into ever more coherent configurations. Evidence: chemical gardens, Belousov-Zhabotinsky reactions, Bernard cells, ecosystem succession. The entire history of life is cooperation, endosymbiosis, mutualism, symbiogenesis. The crystallization. Capitalism is Darwinian in method, but anti-Earth in result. It enforces external selection on systems that evolved through internal self-organization. To align with Earth's mode, replace competition with resonance, replace scarcity with flow, replace elimination with integration, replace survival with coherence. The etheric field. Phi is the physical substrate of this co-creative self-organization. Capitalism is a decoherent perturbation, a local violation of S equals R, that the field will eventually correct.